Mars is thought to have had a much thicker, warmer atmosphere billions of years ago. But how did Mars transition to the cold, thin and dry atmosphere it has today? In order to understand the history of Mars's climate, we must focus on its atmosphere. Our understanding of Mars's atmosphere has been significantly limited by the fixed local time measurements, leaving most of the Mars day-to-night cycle unexplored over much of the planet. Important atmospheric information is missing. Emirates Mars mission, EMM, and its spacecraft HOPE will be able to observe and investigate Mars's lower and upper atmosphere simultaneously. Views of the planet's surface at multiple times of the day will enable unprecedented observations of the physical processes that drive the global atmosphere. EMM will be the first to reveal the connection between these conditions in the lower atmosphere and the escape of hydrogen and oxygen from the upper atmosphere. As these are the building blocks of water, this is a process that may have been responsible for the transition of Mars's climate. The mission will investigate the atmosphere of Mars using a combination of 3 primary scientific instruments to image the planet in the visible, infrared and ultraviolet wavelengths. Emirates Exploration Imager, the EXI, is a multi-band 12-megapixel imager with a dual-channel optic system. It consists of 6 spectral bands covering 3 UV bands and the RGB bands. These bands will not only help us to capture beautiful high-resolution images of Mars, but will also allow us to measure the optical depths of dust and water ice in the Martian atmosphere at 220 nanometers and 320 nanometers respectively, as well as the column abundance of ozone at the 260 nanometer. Emirates Mars Infrared Spectrometer, EMIRS, is an interferometric thermal infrared spectrometer capable of scanning in the 60 to the 40 plus micrometer range using a rotating mirror, allowing us to measure the global distribution of key atmospheric parameters over the Martian day-to-night cycle and year, including dust, ice clouds, water vapor and temperature profiles. EMIRS will also provide the linkages from the lower to the upper atmosphere in conjunction with MUs and EXI observations. The Emirates Mars Ultraviolet Spectrometer, the MUs, is a far ultraviolet spectrometer with a spectral range of 100 to 170 nanometers to make the required observations of ultraviolet emissions of hydrogen, oxygen and carbon monoxide. MUs will measure relative changes in the thermosphere and the structure of both the hydrogen and oxygen exospheres. Additionally, it will measure changes in the structure of the corona with seasons, solar inputs, and lower atmosphere forcing. This will help to determine what is driving changes in the corona.